that it just corrects itself. Okay? So today, we finished with our renal system. Today, we start with chapter 26. My goodness, you're almost done. Hopefully, the worksheets help you a little bit to stay on track, not be on vacation mode. Don't be on vacation mode yet. You can go on vacation when you're done with your final exam. From here on, never forget to bring your books. Always, I always say that, right? But always, please bring your books. So today, we're going to talk about fluid, electrolyte, and acid base. So basically, we're done with our body systems because the last body system, reproductive system, is how to maintain the human race. How we, it just talks about how are we capable of becoming a father or a mother, maintaining the human race. So we're done. The how we function every day, we've already studied all the body systems. Now we know that we are made up of electrolytes, we're made up of water, we talked about the different proteins, the different nutrients. Now we're going to look at these different electrolytes and the importance of normal levels of these different uh, chemicals that we have in the body. We talked about the organic nutrients. We know the importance of the fat, the protein, the glucose. Now, this is the next one in the limelight. This fluid, electrolyte, and acid-base balance. So first, let's look at this one. Oh, first you need to know these following terms. I'm sure you know. Where do we find the fluid? You should know intracellular, extracellular. You know that, right? So fluid, which is mainly what? What's the main composition of fluid? Is yes, it's mainly water, right? So most of it is inside the cell, but everything that's outside the cell you call as extracellular fluid. But there are some special extracellular fluid have a special function, so you give them name. Like plasma is also extracellular fluid, right? Lymph, that's also extracellular fluid. You know of any other? CSF also. You see the difference? Okay, intracellular, extracellular. And you remember that water follows salt. Water moves by osmosis, right? That's why I think one famous or not one way of trying to drink clean water, they call it reverse osmosis. If you think about it, osmosis follows, where there's high concentration of solids. Reverse osmosis is you're pulling out just pure water. That's why they say this is better water. By reverse osmosis, it's going to be free of all of those sediments because water follows the salt. But for us, water does follow salt. So, knowing that water follows salt, it's important to be in fluid balance. Look at this one. I just saw this on the internet. It's amazing. When we were, why do this opens our eyes to the importance of being in water balance. Look at when we were first formed in our mother's belly, 100% water. Then the baby, no wonder when if you have babies, when they have diarrhea, they get dehydrated very quickly. Okay? And then normal adult, that's you, because I'm over here. 50. Look at you, 70% water. So that's why if you're lacking in water, it may affect your performance. Look at where this water is. Your blood, 85% water. Your brain, look at this. So that's why if you don't drink water, do you think you'll be able to do well when you take the test? No. Like our children, with Lilia, always nag her, drink your water. I always want to know how many times did she replace her water bottle. Because they get, what do you call that? They're distracted, play. Or even with school, the recess time is only very limited. So they eat and then they just want to have more time to play. And then they don't. they forget to drink. So look at, very important in your muscles. See, when we're dehydrated, we can have muscle pain. And just basically, 90% water is what makes up your cells. So it's very important to be in water balance. How do we balance this water? So where do we lose water? Look at mainly through your kidneys, right? Then some of it in your skin, some of it through your lungs. But look at the amount, 1,500 mils through your kidneys. So I'm thinking if I want to do water balance or control, this is the main way that will help me to balance my water, right? How do I, where is my water coming from? Of course, the liquid that I drink, my water, my juice, also from food. We know that, right? Especially carbohydrate, there's water in there. And what is this metabolic water? Can you guess? I know you know it. Metabolic water is from?
After metabolic.
Yes, very good. For metabolism. Remember, when we break down our carbs, remember what's the breakdown products of metabolism? Do you remember? It's ATP plus water, remember, plus carbon dioxide plus heat. So in your mitochondria, remember, you send your glucose there, your fat or your protein. This is your breakdown product. So this is referred to as metabolic water. Okay? So they have to be balanced. It has to be balanced because of where you find water. It's the main component. And isn't it the key to keeping the shape of our cells water? Like the balloon. Think about the balloon. If it's not nice shape like that, so pretend that the balloon is filled with water and not air. If the balloon gets deflated, it won't be able to do its shape. That's the same thing with our cells. Okay? This next slide is how we maintain homeostasis, water homeostasis. Remember, look at this one, thirst. This slide is telling us, and even your book says so, when you feel thirsty, that means you are already dehydrated. See, you're thirsty. So that's why we don't want to wait for that thirst to reach for water. In fact, what did they say? For normal females, we should drink 9 to 13 cups a day. For males, what did they say? For males, it's how many cups a day? 13 to 16 cups a day. But that's just normal. If you're physically active, you have to increase your water intake. And thankfully, we have the hypothalamus, H for homeostasis. Okay? So your hypothalamus, if it's receiving blood that's low in water, you have osmoreceptors there. So they trigger the thirst center. Then you become thirsty and you increase your water intake. At the same time, there is another uh, body system that helps in water balance. I'm sure you can guess what it is. It is your what? What other body system helps in water balance? Like when you're dehydrated, what do you think will help? So this one is our thirst, but the kidney can help us. So what is it? The renal system through what? Through what will be released when you're thirsty? What is being released? Hormones, right? The endocrine system helps. So you remember when this is released, antidiuretic hormone? But you're right, the renal system. So when you're dehydrated, the kidneys will receive blood that's low in volume, right? So remember, the kidneys release the enzyme renin, which converts angiotensinogen to angiotensin. And at the same time, that's why it's called renin-angiotensin aldosterone system. Then goes to release aldosterone from your adrenal glands. And at the same time, antidiuretic hormone being secreted by your pituitary. Remember, the ADH is released by your hypothalamus. It's made by your hypothalamus, really, and stored in your posterior pituitary. So, in addition to just nervous system that triggers your thirst, you interpret it as thirst. At the same time, your endocrine system is also already working in the background just to make sure that you keep the water volume. So this is what happens when you're dehydrated. Okay? Don't forget the major hormone regulating water, and it makes sense, right? Antidiuretic. So you look at this slide should make you appreciate how dangerous it is to be dehydrated. Look at so many hormones all of a sudden, all of them being released at the same time to prevent more water loss and conserve whatever water we have because dehydration is dangerous. Now, look at what happens when there's too much water. When there's too much water, there is only one hormone that helps us with that, right? It is called atrial natriuretic peptide right here. So, so many hormones to prevent water loss, but just one to promote the release of water, atrial natriuretic peptide. Because we're not designed to have too much water. Because our kidneys it automatically rains. And that's why, remember that lady, hold your wee for a wee? She refused the kidney in doing its job. Does that sentence make sense? She made the kidney not do its job because she was holding her feet. If we just pay attention or let our body do its job, the kidney just automatically, see, will get rid of excess water. So that's why there's only one atrial natriuretic peptide. Where is this being released from the atria of the heart? So if there's increased blood volume, it expands, right? The return of blood into the atrium is a lot. It expands the atria, and they respond by releasing this hormone. And then it goes to your kidney to promote natriuresis, or the release of salty water from your PP. And that's how you maintain water balance. Too much water can lead to what we call water intoxication. And this is most commonly because of just drinking just plain water. And what happens is you expand your plasma, increase blood volume. Remember, water just follows. It moves by osmosis, remember? That's why we needed to remember hypotonic, isotonic, and hypertonic solution. Do you remember that? Because that will come out in your test again. You remember the exposure of cells to hypotonic, isotonic, and hypertonic solution. It's very important for you guys to remember that. And this is why when you start working in the hospital, there's so many different IV fluids. There's the 0.9%. That's just normal. That's isotonic. Then you have the dextrose, which is sugar, which is hypertonic. And so then that keeps that's what you usually give for those who are just extremely dehydrated, right? Or maybe those who are anorexic, you give them that because it's also loaded in sugar. But you see, you have to watch out. Be careful in those different kinds of IV fluids that you're going to give your patient because they have different functions. And also because water follows salt. It can cause the death of your patient. Very, very important for you to know. And also because water is the key for the shape of every cell. You did your histology. You saw how different cells have different shapes. The shape is the key to maintaining their function. So that's why it's important to be in water fast. Look at what happens when you develop water intoxication. You can also die. They go into convulsions, then they go into coma. And this is exactly what happened to that woman. Within 12 hours after winning the Wii, she started having convulsions. Her mother brought her because I think her husband was working, brought her to the hospital, and then she died. Then the husband won millions of dollars, didn't he? But he said, my wife is gone. That's because they didn't realize that water moves. It follows the law of physics. You have any questions on water? Don't remember. Don't remember the hormones. Don't forget the hormones are ADH, aldosterone. No need to talk about those hormones, right? You understand. Antidiuretic hormone released by your brain, the pituitary, right? Aldosterone from your adrenals that goes to the kidney. Both of them goes to the kidney. Why is the kidney the target for water balance? Because it is the main organ that has the capacity of, see, getting rid or conserving a large volume of water. What I get rid of through my GI tract, only 100 tests. Lungs, only 300. Skin, only 600. Look at your kidney. So this, it makes sense that the target of your nervous system and your endocrine system will be this one. This is the one that can just very quickly help us. Okay, you have any questions on water? Now we talk about any questions? I didn't even, no questions. Water balance. Now we're looking at electrolytes in the body. We've studied these electrolytes. You know how important sodium, potassium is in your nerve conduction, right? Remember your chemical gates, your voltage gates, your mechanical gates. These are nothing but sodium and potassium gates. Remember when we were talking about the nervous system? You remember how calcium is important for muscle contraction? So, in other words, electrolytes are important because they have a function. A lot of them also serve as cofactors. What's a cofactor? A cofactor is a helper of enzymes. And enzymes are key for metabolism, you know that. Another very important type of cofactor is actually your vitamins. That's why we need to take our vitamins. But see, look at carry electrical current. They're important for acid-base balance. They're important for water balance. So we need to make sure that we are always in electrolyte balance. There are several electrolytes that the body discusses. Okay, now I want you to remember this slide. So where do we find the electrolytes? We find them inside the cell or outside the cell. This came out in the test. So you have two types of electrolytes, right? Cations and anions. So first, inside the cell. See? Intracellular, the yellow one. So the most abundant cation inside the cell is potassium. You know that, right? And the most abundant cation outside is sodium. So I'm going to ask you this in the test. What's the most abundant cation inside the cell? You should know this, automatic. Okay, even when you start working. And this is why, see, extracellular is sodium. That's why a lot of the IV fluids we give have sodium. Sodium chloride, 0.9, 1.2% sodium chloride, lots of sodium. Potassium is most abundant inside. Now we look at the anion. The most abundant anion, negatively charged electrolytes inside is phosphates. Outside the cell, the most abundant anion, of course, sodium bonds with chloride, it's chloride. So if you remember sodium outside, potassium inside, potassium phosphate, sodium chloride. Then my next question will be predict what will happen if, let's say, there's a deficiency of those electrolytes. That's how you will be tested on this electrolyte balance. So first, let's look at sodium. Again, this is the most abundant cation extracellularly outside the cell. Look at, we need to be in sodium balance. That's why you have these hormones. You know what these hormones do now? No problem, right? Aldosterone is your salt-retaining hormone, and then antidiuretic hormone. This is your water-retaining, but see, if sodium is too low, the ADH release stops. So that's why we have to be in sodium balance. If there's too much sodium, this is the one. This is opposite. If there's too much sodium, atrial natriuretic peptide increases sodium release. Write down in your notes. Automatic you think. If there's a sodium imbalance, you think blood pressure problems. That is the first thing. So when you read your book, you will see that sodium deficiency, sodium excess you will affect your nervous system, your heart, muscle, etc., etc. But the first thing that should come to your mind when you start working, practicing in the whatever, first thing that should come to your mind when a patient comes in sodium imbalance, look at blood pressure right away. Okay? This is the key for maintaining blood volume. You know, salt water. Salt attracts water. When we eat something salty, we feel bloated. So always think blood volume. Okay? So what is the hormone that is key to sodium balance? This is the one, aldosterone. And then the opposite is atrial natriuretic peptide. But remember this aldosterone. Okay? In fact, aldosterone is also key for maintaining potassium balance. Next is chloride. This is the most abundant anion outside the cell. So, along with sodium balance, the aldosterone also is key for maintaining chloride because sodium always binds with chloride. And so if you're in sodium balance, you automatically should be in chloride balance also. It's the key for maintaining acid-base balance. Chloride bonds with hydrogen, remember, to form that hydrochloric acid that you produce in your stomach. But then the next very important ion that I want you to know that has some uh, clues as to the condition of the individual is potassium. This is the most abundant cation inside the cell. Look at this one. Write down, see, highlight this one. If you have potassium problems, automatically think nervous system. Okay? So this is your neuron. Remember, there's your neuron. And potassium is most abundant inside. So let's see. Oh, by the way, if there's too much sodium, that condition is called hypernatremia. Sodium. If it's low sodium, it's hyponatremia. Now, if it's too much potassium, it's hyperkalemia. Potassium deficiency is hypokalemia. So letter K. So look at this one. If you have hyperkalemia, that means there's too much potassium outside. So it will diffuse inside. Right? Do you follow? It will diffuse inside. So what will that do to the charge of the neuron? Remember, it's at rest, it's -70. What will that do to the charge of the neuron? Make it more negative or less negative? Less negative. So that means if you have hyperkalemia, if you have too much potassium, it may lead to increased nervous activity and eventually lead to convulsions. That's why we don't want hyperkalemia. Predict what will happen if it's hypokalemia.
More negative.
So, more negative. So, you cannot stimulate this neuron as easily. So, they become listless. Then, eventually, maybe they go into a coma. See? Remember, what are we going to think about sodium? Always think blood volume right away, blood pressure. Now, potassium, think nervous system. And like I said, eventually all these electrolytes will affect every part of the body. But that's, I don't know, that's just the first thing that we think. It targets nervous system first and then the rest. Sodium targets blood volume first and then the rest. Now, oh, and also what regulates their balance potassium is aldosterone also. Aldosterone. Next is bicarbonate. We're going to talk about this when we talk about acid-base balance, okay? Which is our next one in a few minutes. But this is very important. We're going to talk about this. I just want to finish up with the rest of the electrolytes. Now, calcium. Next to calcium, think heart. See, they have their own field of expertise. Sodium, blood volume. Potassium, your brain, nervous system. Calcium, when a patient comes in, calcium imbalance, automatic. Think heart right away. Okay? So that's why we need to be in calcium balance. And you know there are two hormones for calcium homeostasis. We talked about this. And maybe you forgot. Parathyroid hormone and calcitonin, remember that? Right? See, heart, automatic, we think heart. Now it makes sense that God made sure that we have a good bank from head to toe of calcium. See, we have lots of calcium stored right here because any imbalance of this one automatically targets heart. Again, don't forget, eventually it affects every part of the body. Okay? But those are the things, the key features you look for right away. So patient comes in, blood pressure, you look for sodium, electrolyte abnormalities first. Then you have a patient, maybe brain, look for potassium. So at least you have an immediate plan of action, is what I guess we're trying to help when you start working out there. Okay. With calcium, is there oh, okay, so you say hypocalcemia, you know that, right? Hypocalcemia, that's low calcium. And then hyper is too much calcium. Okay. So hypercalcemia can be dangerous because you can maximize your 401k right here, right? When there's still too much calcium, you can start calcifying organs other than your bone. So you want to be careful. Of course, your kidneys will try as much as possible to get rid of the extra calcium that you take in. You see, if we only will drink our water, it will solve our problem of accumulating excess of all these things. Because the way for our kidneys to work is they need water. So, when we develop hypercalcemia and our kidneys are not able to get rid of it for some reason, then other organs other than the bone can be calcified. And you know that. I'm sure you've seen some patients with maybe calcification. You've seen some patients with some, like a tumor. You see them with like tumor, some in other parts of the body. And I've seen it a lot in dogs and cats. And then they do a biopsy. It's just calcification. But it's not only under the skin. You can have calcification in your heart, calcification anywhere in the body, even in your uterus. Will it be able to do its job? No, not anymore. So we want to be careful also with too much of any of these electrolytes. The last electrolyte I want to touch on is magnesium, only because it's one of those electrolytes that I think we neglect, but it is very important. It's, you know of Epsom salt, right? When we have muscle aches, they say lay down, or what do you call it, a hot tub with Epsom salt, which is magnesium sulfate. So magnesium automatically think muscle, skeletal muscle. If you work in the OBGYN ward, a lot of patients who go into preeclampsia, or you will encounter these patients, hypertensive patient, pregnant, and they immediately, you will see, they will order magnesium sulfate injection because magnesium is a relaxant. So if you have a pregnant patient, blood pressure increasing, and especially for some reason, they will start complaining of a headache. When they say, "Oh, I have a headache," oh, you should immediately infuse that. The next step that will happen, they'll go into abnormal labor and maybe even convulsion, they deliver the baby prematurely. So inject magnesium right away. So magnesium relaxes muscle. Sometimes, when we exercise or when you have too much muscle strain, they will tell you eat magnesium rich foods, or they give you magnesium salts, or what do you call it, magnesium tablets. You will ask, why do I need this? I'm sure they will tell you because M for muscle relaxation. It helps to relax your muscles. Okay? There's another benefit to magnesium homeostasis, and that is glucose. Magnesium actually helps insulin in doing its job. So magnesium, normal levels of magnesium helps in glucose homeostasis. And so if you are lacking in magnesium, maybe that increases your risk for developing the diabetes. Magnesium is also key for sexual development. There was an area in some of those Middle Eastern countries where they discovered the importance of magnesium for sexual development. They It's key for the secondary sex organs, your sex organs to develop. And so if you are lacking in magnesium, may become a dwarf because the sex hormones are growth, right? And they are not developed or matured sexually. So those are the electrolytes that I want you to know. This is a summary. Remember, sodium, think blood pressure. Potassium, so the key, I want you to know sodium, potassium, calcium, magnesium. Potassium, think nervous system. Calcium, think heart. Magnesium, muscle, skeletal muscle. And so the test for this one usually is fill in the blanks. Maybe, maybe not, I don't know. But in the past, the most abundant intracellular cation is blank. So you're gonna write potassium. Then, um, and then the next question will be predict what will happen if there's decreased levels of this one. Maybe predict what will happen to your brain. Predict what will happen to whatever. So that's how you will be tested. You have any questions? The next part is acid-base balance. You can take a break for 5 minutes. Then we talk about acid-base balance. Then I have worksheets for you. By the way, this is exciting. This is fun, and you're gonna have activities on acid-base balance. What you need to know? Do you agree? There is a normal pH. You need to know these values, okay? Which I'm going to give you if you forget. But the normal pH is 7.35 to 7.45. You know you. I hope that you can memorize these numbers. But if you cannot, then maybe I'll write it down. But it's so easy, 7.35 to 7.45. So look at the one thing I want you to appreciate about this number. Do you see there's just a very narrow window of give, just point 0.1. You have to maintain this acid-base balance at all times. Why? What is the most abundant organic compound that the body is made of is protein. And you know that proteins can be denatured by too much acid, right? Or too much base. Between acid and base, a normal day-to-day activities will most likely exposed us to acidic conditions than basic conditions. Basic conditions mainly diet related. So acid, coffee is acidic, orange juice acidic, too much exercise, lactic acid, or if we don't like to breathe, hold our breath. So carbon dioxide, you remember carbon dioxide combines with water to form carbonic acid. So we always have a tendency to go into what you call acidosis. With acidosis, is the pH high or low?
No.
Low. Don't forget that, okay? I remember in your final exam, the higher the pH, the more acidic the condition will be. That's false. So remember, with acidosis, the pH goes down. With alkalosis, the pH goes up. Okay? So moment by moment, just like anything, our carbon dioxide level, we also vacillate between, we don't, maybe we go into acidosis a little bit, but thankfully, we have automatic, again, you see, we have body systems that try to maintain acid-base balance. We need to be in balance. If we are not able to control this balance, that's when we suffer consequences. You can develop nervous problems because everything, the main component of everything is protein. Okay? So, look at these three major components that regulate pH. This is what you call buffer. You see the word buffer. Of these three, look at this one, exhalation. You exhale the carbon dioxide. When you exhale the carbon dioxide, it's released out of the body, right? You get rid of it. You solve it permanently. When you get rid of it to your kidneys, you solve it permanently also. Okay? You agree? However, this is where we appreciate our buffer. So look at, we build up acid products or basic products, not in your kidneys right away or your lungs right away. Maybe they're built up in your legs or in your brain, wherever. It's not in your kidneys right away. So that's what you have to send it, right? The acid product that was built up, let's say in my legs because I'm running, it has to move. You have to move it out of the legs all the way to the kidneys. Can you imagine if it remained that strong acid, lactic acid, let's say, if it remained like that all the way, then it will cause damage to the neighboring cells as it gets delivered to your lungs or your kidneys. Do you understand? This is why we have the buffer. What the buffer does, and we're going to talk about a few buffer systems. The buffer is a temporary fix. This is the one that gets rid of your acid or your base products permanently. This is temporary, the buffer. What it does is it converts the strong acid or the strong base to a weaker acid or a weaker base on its way out.
Is that like turning ammonia into urea?
Yes, very good. Just something like that. Like the bouncer, if there's trouble that's about to happen in the club, the bouncer comes, right? Buffers this pain in the butt, kick him out the door. But on the way out the door, if there was no bouncer, then maybe this guy will cause trouble, punch everyone in the face on the way out. See? So, what is the buffer? That's the bouncer. Don't write bouncer. Anyway, so see, it's a temporary fix. It does not remove. It's not able to get rid of your acid or your base. Okay? The only one that has the ability to do that is your lungs and your respiratory system. So let's look at these different buffers right here, the next slide. See, you have buffers inside the cell, is your phosphates, and inside the red blood cell, unique to the red blood cell is your hemoglobin. Then outside the cell, you have your bicarbonate buffer system. And then in between the two, the proteins, the amino, which is basic, then the acid part. So they can buffer. If you have too much acid, too much base, they can buffer. Again, buffer is just a temporary fix. So let's look at this one. See? Like the amino acid. You're not going to be asked how this happens, but this is how, look at, there's your amino acid, there's the amino group, and then there's the acid group. So, in alkaline medium, the amino acid acts as an acid. It can be acid if the pH is high. If the pH is high. And then if the pH is low, it can act as a base. That's what it means, to neutralize on its way out. That's the same thing with your carbonic acid, bicarb. So it can be acid if it's too much base. It can be a base if it's too acidic, the conditions. But it just neutralizes the pH on its way out. Now I want you to look at the important body systems that will get rid of it. Your respiratory system and your renal system. Of the two body systems, which one do you think is more important? Is more effective? Respiratory or renal system? What do you think? Who says respiratory? Who says renal system? I say renal system. Why? Because the respiratory system can get rid of only one, that is CO2. The renal system can get rid of anything or everything else. Even the CO2, you can get rid of it through your renal system by combining it carbonic acid, right? So between the two, that's why it's more dangerous to be in renal failure, right, than respiratory. So we're gonna have acid-base balance activities right now, and I want you to turn. You have your textbook. You go to here, page 1019. A closer look. ABG analysis. It's even giving you the normal values. Okay. So you have there. You see. Look at the normal pH is 7.35 to 7.45. The normal pH. How do I know the PCO2? How do I remember? Look at the 35 and 45. So if you know the pH, you can memorize the normal carbon dioxide. The bicarb is the only one that maybe you'll have a little bit of help to remember. But as you use it, you remember 22 to 26. Some books write 21 to 27. But for this textbook, we're using 22 to 26. So the first thing, how do you know? You've heard of ABG analysis? All of us will go through different stages. We can be in acidosis or alkalosis. I'll give you some different examples. You'll see. This is part of it. When you hyperventilate or when you eat too much. When you eat too much, let's say, too much steak, right? Steak is amino acid. You can go into acidosis. So at that point, you were in acidosis. We just don't feel the effects because we have a healthy functioning respiratory and renal system. So when the pH, so how do we go about? There will be three values that you will be given in our practice test and in your lecture test. So first, you will be given the value of the pH, and then you'll be given PCO2 values. So you should know the pH is normal, 7.35 to 7.45. And then the PCO2 normal is 35 to 45. And then the bicarb is 22 to 26. So you should know these values. The first thing that you will check if you have ABG analysis, look at the pH. If the pH is low, then you're going to write the patient is in acidosis. Now, I just want to know, is the patient in respiratory acidosis or metabolic? If the bicarb is low or if the bicarb is the problem, you say the patient has a metabolic problem. If the PCO2 is the one that's the problem, and then it's a respiratory problem. Are you following so far? So let's say, look at this one. The patient is in acidosis. Maybe let's put a real number. Maybe the pH is 7.32. 7.32. So it's less than 7.35. So I say the patient is in acidosis. Then I'm going to next look at the PCO2. The PCO2 is, let's say, 7.5. If the PCO2 is high, the higher the carbon, not that, the higher the carbon dioxide, that means the patient is in acidosis. More carbon dioxide accumulation leads to acidosis. I'm sure you remember that, right? The more carbon dioxide you have in the body, the more tendency that you go into acidosis. So here in this example, the pH of the patient is 7.32 acidosis. The the bicarb, let's say the bicarb, this is the bicarb, let's say it's not increased. Oh, here, first if it's increased, then I know automatically if the PCO2 is increased, then I know automatically the patient is in respiratory acidosis. Okay? So maybe the patient is not breathing. Then we look at the next value, the bicarb. If the bicarb is increasing, look at this picture over here. It's very, we're going to have samples. And once you're done with this class, you're going to know it very easy. They compensate, okay? If the lung is not working, then the kidneys have to compensate. If the kidney is not working, then the lungs will have to compensate. Okay? So you can either be in compensating or not compensated. Let's again look at this part right here. I took the pH and the pH is low. I know the patient is in acidosis. Then I look at the PCO2 is high. So 7.5. You know that the PCO2 value is 35 to 45, right? And the not 7.5, the PCO2 of this individual may be 51 or it's high. The normal is 35 to 45. The higher the carbon dioxide, the more tendency to go into acidosis. Because the PCO2 of this individual is high, and I look at the pH, the patient is in acidosis, I'm going to say that the condition of this individual is respiratory acidosis. You understand this part so far? Now, the next value, APG analysis always gives us this value, then this, always these three values. Now I look at the bicarb. The bicarb of this individual is increased. So maybe it's 29. The normal bicarb is 22 to 26, remember? So if it's increased, what is this telling me? It's telling me that my kidney is trying to correct the problem already. You see that? Again, here, what's the normal? PCO2 is 35 to 45, normal, right? But for this patient, it's increased. And the pH, it's in acidosis, so the patient is in respiratory acidosis. I know that. Now I'm going to look at the third value, the bicarb. For this patient, the bicarb is high. It's higher than normal. So the bicarb is trying to neutralize or to correct the condition of the patient. So I'm going to write compensating not compensated, compensating respiratory acidosis. Okay? There is a difference between compensating and compensated. And you're going to see when we start our practice. When the pH is already corrected, then you say the condition has already compensated. This has compensated properly. But this is still compensating because the pH is still not normal. For your lecture test, I will give you example. No, I will give you the clinical scenario, not just numbers. So it will be easy for you to study. Now look at this one right here. If the pH is, the patient is in acidosis, still 7.33 acidosis. I looked at the PCO2. If the PCO2 is normal, then I'm going to say the patient must be in metabolic acidosis. Then I look at your, if the PCO2 is going down, then the patient's condition is compensating. You understand? So PCO2. If the PCO2 is going up, this is acidosis. If the PCO2 is going down, this leads to alkalosis. How about the bicarb? If the bicarb is going up, that's alkalosis. If the bicarb is going down, that's acidosis. Do you get this one first? If the PCO2 is going up, acidosis. If the PCO2 is up and the patient is in acidosis, what do you think will happen to the bicarb to correct this? Will the bicarb go up or down? Yes, very good. Okay. How about this one? If the patient is in metabolic acidosis, the bicarb is down. So the patient is in acidosis. How do you think the PCO2 will, if the PCO2 is helping, what will be the direction of this one? Up or down? Down. Down. See? Acidosis, how do you correct metabolic acidosis? Alkalosis. Let's look at now different examples. Remember, if the kidney is not working, the lungs will have to help. If the lungs is not working, the kidneys will have to help. And between the two, your kidney is the most efficient. Let's practice. Let's do this ABG practice first. Let's see, you will be able to get this. It's confusing at first. So again, this is how it will look like. You'll be given, but the test you will be given as it will, after this one, the next PowerPoint will show you different clinical scenarios. So what about if you're just given this one? First, you always need to remember the normal pH, 7.35 to 7.45. The PCO2 is 35 to 45. And then the bicarb is 22 to 26. So, what is our interpretation of this one?
Healthy.
Normal. This is normal, right? This is normal, normal, normal. So I'm going to write normal ABG. You understand? This first ABG is normal. Let's look at the next ABG. Okay, how about the next one? Here. This is, what's this one? Normal, right? What's this one?
That was low.
Low. So if the PCO2 is low, I'm going to write this must have been alkalosis, respiratory alkalosis. What about this one?
Low.
Low. So this is acidosis. So the interpretation, the possible, that's why it's very important to get the clinical analysis. Maybe the patient was in metabolic acidosis, corrected or compensated already. You see how they compensated? Or maybe the patient was in respiratory alkalosis, compensated. So maybe I'll say a 19-year-old individual was hyperventilating because she got into a terrible car crash and she's hyperventilating. Then ABG analysis shows the following. So the clinical scenario says the patient was hyperventilating. So you predict respiratory. So you're gonna say respiratory alkalosis compensated. It's already compensated because the pH went back to normal. Maybe, how about I can say, 10-year-old baby has comes to the hospital with diarrhea, and this is the ABG. So diarrhea, can that be a respiratory problem? No, metabolic. So I'm gonna write, and this is the ABG. So my interpretation will be metabolic acidosis compensated. It's compensated or it's normal. You understand? That's why it's easy. ABG is very easy. Okay? Okay? Let's look at the next ABG. Okay, what's this one? First, we're going to write high or low.
It's high.
So it is alkalosis. Very good. How about this one?
That one is normal.
Normal. So normal. And then,
That one high.
so what's our diagnosis? No,
Alcohol.
metabolic alkalosis uncompensated. Because, why is the word uncompensated? Because this is still not normal and this is not even working yet. So it's uncompensated. Metabolic alkalosis. You see that? This is an example of patients maybe who have vomiting because you're vomiting acidic stomach content. So you're getting rid of the acid. You go into metabolic alkalosis. Or maybe ingesting too much alkaline, maybe too much vegetables, maybe mostly alkaline. So you go into metabolic alkalosis. I predict eventually, maybe when I check, maybe 15 minutes from now, and the ABG. How about if the ABG read 7.45 and then the PCO2 maybe went down or maybe went up to 50, and then the bicarb is 29. So you see, look at this one. What are we going to write for this one? So this one normal, right? This one acid, right? This one basic. So what happened now? This is the same patient. I checked the ABG 15 minutes later. See, now the patient is still metabolic alkalosis, but it is now compensated because the pH went back to normal. You understand now? It's very easy. Now let's look at the next one. This is the part that students enjoy the most. Once they understand how to do ABG, it's so much fun. Look at this one. What's this one? Yes, very good. So I'm going to write acidosis. Oh my goodness. So high or low?
High.
High. So must be respiratory acidosis, right? The bicarb,
Is not
normal. So what's our diagnosis? Respiratory acidosis, uncompensated, because the pH is still normal and this one is not even moving. If this is already moving, then I'm going to say it's compensating, right? It's not moving yet. Okay? So this must be, let's say, emphysema patients. They can't get rid of it, so they go into respiratory acidosis. Okay? Let's look at the next one. What's this one? Normal. Low, so that must be, if it's low, is it acidosis or alkalosis? Alkalosis, right? The higher the carbon dioxide, we say acidosis. Low carbon dioxide, alkalosis. And then the bicarb is low, so this is acidosis. So I'm gonna write, it depends on the condition, okay? I'm always gonna make sure that there's a clinical scenario. So maybe I can write respiratory alkalosis compensated, or metabolic acidosis compensated. Maybe I'll write patient comes in overdose of aspirin. This is the ABG. So automatic, I know it's a metabolic problem, right? But I looked at the ABG and this is the result. So I'm going to write metabolic acidosis compensated. Or maybe I'll say this is a patient, like the hyperventilation patient, right? With the car crash. So you're gonna say the patient was in respiratory alkalosis, hyperventilating, but the pH is normal, so that's compensated already. Okay. How about this one? Alkalosis. So this is alkalosis. What's this one saying?
That is too low, so it's alkalosis.
Alkalosis also, right? If the PCO2 is low, that's alkalosis, don't forget. And then the bicarb is
It's normal.
normal.
So
what's the condition?
Respiratory.
Respiratory alkalosis what? Uncompensated. Very good. Because this is not even moving yet. See? You got it. It's not hard. Okay? Very good. Then this one. Whoa. This is
Normal.
normal. This is
Acidosis.
acidosis. This is alkalosis. So maybe we'll write respiratory acidosis compensated. Or maybe metabolic alkalosis was the problem, compensated. Because this went to normal already. Understand? Okay? This one. Acidosis. Normal, right? 35 to 45. And then the bicarb, so acidosis. So metabolic acidosis uncompensated because the pH is still, so metabolic acidosis, and these are the diabetics. They go into metabolic acidosis, ketoacidosis. When they don't take their insulin, they switch to plan B, meaning they start burning the fat. So they accumulate a lot of ketone bodies, they go into ketosis. You look at their pH, it looks like this. Then eventually you predict with that individual, if they don't take care of it metabolically, you predict increased respiratory rate to compensate for this one. We need to get rid of it, right? The acid. But the only problem, the only thing you can get rid of in your lungs is just carbon dioxide. Every other waste product is through your kidneys. What about this one?
Alkalosis.
Yes, alkalosis.
It is normal.
Normal.
Not entire.
So, metabolic alkalosis. Uncompensated. Because this is still not moving. It's still normal. You see? Okay? I'm gonna let you practice the others, but let's now go to there's others. There's lots of others here. Not that much, but let's look at this other one that has this one. This is how you're going to be tested. Here. this is fun. I like this one. Very easy. This is how you're going to be tested in the lecture test. There'll be clinical scenario. So here, and you should get your clue. As you read the problem here. See, 62-year-old patient, productive cough. So I'm thinking the problem must be respiratory already, right? Pneumonia. There's no metabolic here. So this is the pH is 7.27. So is this high or low? Low. So it's acidosis already. And then the PCO2 is high, right? 58, the PCO2. And the CO2, it should be 35 to 45, and this is high. So I'm going to say respiratory acidosis. And look at the bicarb is 60. So it's increasing. So the bicarb is trying to correct this respiratory acidosis already. Do you follow? So what will be my diagnosis here? I'm going to write respiratory acidosis compensating because the bicarb is also high. It's trying to compensate or correct the problem. Did you get that? Yes? No? What you think? Okay. How about this? Can you read it? Okay. How about this one now? Obsessive compulsive severe anxiety attack. So let's see. I don't know if it will be respiratory. Tingling in shortness of breath. So must be respiratory also, right? So 7.54. Alkalosis, acidosis. Alkalosis. Then this one, the carbon dioxide is low, right? So respiratory alkalosis. And then the bicarb is oh no, there's your bicarb. Sorry, bicarb is here. The bicarb is low. Bicarb is low, right? The normal bicarb is 22 to 29. So if the bicarb is low, what's that you're gonna write acidosis, right? So what's my diagnosis? Respiratory alkalosis because of the clinical picture here, compensating. Okay, you got that? Let's look at the next one. Oh, now vomiting. So I know this must be metabolic, right? So vomiting, I'm thinking metabolic. Then the pH, 7.58. So that must be alkalosis, right? Metabolic alkalosis maybe. And look at the bicarb is high. So obviously metabolic alkalosis. But look at the carbon dioxide. The carbon dioxide is 55. Is this high or low? Remember, what's the normal carbon dioxide? 35 to 45, right? So this is high. So what am I going to try? Compensating or compensated? Compensating because the pH is still not normal. So metabolic alkalosis compensating. Why is it compensating? The carbon dioxide is slowly creeping up. So the acid is trying to correct the alkalosis of the patient. How about this one? Cirrhosis. So I'm thinking metabolic also. Okay? So metabolic, let's see. I'll call this and look at the bicarb is 70. And then the ABG. So bicarb is low. So and then the ABG is normal. I don't know, that's high. So alkalosis. So the pH is high, that's alkalosis. The bicarb is low, so that must be acidosis. And then the PCO2 is low. So I'm going to write compensating. Then, how can this be? Oh no, the bicarb on her room air. The bicarb here, the bicarb is 16. It's still low. This is the one. It's still low, so acidosis. The bicarb is in acidosis, but the pH is high, and then the carbon dioxide is low. So if the carbon dioxide is low, it's alkalosis, and then this one is acidosis. Huh? The patient is in
So there.
significant source of secondary to alcoholism. New patient visit. Oh my goodness, what is this problem here? So I'm thinking it's metabolic. But look at the bicarb is low, 16. So that should be acidosis, but the pH is high.
So
So that's alkalosis. And the carbon dioxide is low. So this is respiratory alkalosis. Com-
yeah.
Compensating.
Yeah.
But how can it be respiratory? Look at that. It didn't say any respiratory. I'm reading this. I'm gonna write metabolic. I can't say metabolic alkalosis because the bicarb is low. We just read it. It's respiratory alkalosis compensating. But this confuses me.
When she first came in, her bicarb was 17.
Huh?
And then it dropped to 16.
Oh,
It says that. When she first came in, her bicarb was 17.
and then it's going down.
It dropped to 16. This, let's say they gave her O2 or anything like that.
That's why I'm thinking must be acidosis. But why is the reading respiratory alkalosis compensating? Isn't it respiratory alkalosis? Because this is alkalosis, the pH is high. If the pH is high, it's alkalosis. And then the bicarb is low. If the bicarb is low, that's acidosis. Here, the carbon dioxide is low. And so that's why I'm going to read this respiratory alkalosis compensating. This one,
I would say this patient's probably on
maybe.
like 2 years to recover.
But do you understand why it's respiratory alkalosis compensating based on the ABG? Okay? So let's look at the next one. So that's how you're going to answer. Okay, let's look at this next one. 18-year-old, ulcerative colitis. I'm also going to say metabolic just by looking at the problem. Let's look at the pH. So this one is low, so acidosis, right? The pH is low. The PCO2 is low, so that's alkalosis. And then the bicarb is low, so acidosis. So it's obviously metabolic acidosis compensating. Okay?
So what is that last measurement? The 90 level?
90, that's the O2 sat, oxygen saturation.
Oh, okay.
Yeah. They should just use this one here. Okay. Now I'm gonna let you practice this one at home, but I have a worksheet for you guys. Or you want to practice this? Let's practice two more. Let's see. This one, pulmonary fibrosis. So obviously I'm predicting a respiratory. Let's look at pH normal. The PCO2 is high, so respiratory alkalosis, and then the bicarb is high. Oh, here, look at this one. So I'm gonna write if sorry, acidosis. If the PCO2 is high, it's acidosis, right? If the PCO2 is high, acidosis. If the PCO2 is low, alkalosis. If the bicarb is high, alkalosis. If the bicarb is low, acidosis. So this patient was in respiratory acidosis compensated. Okay? Okay? Then next this one, 7.43. So pregnant woman, old pregnant. Why do they have to write old? Normal. And then the PCO2 is low, so that's alkalosis. And then the bicarb is low, so that's acidosis. So the patient must have been in respiratory alkalosis compensated or metabolic acidosis compensated, depending on what the condition of this one. Okay? Okay. So now let's I'm gonna give you practice worksheets. This one is good for you to practice at home. There's a lot of them here. Hopefully you can take advantage of this one. But I'm going to give you a worksheet right now and it's going to be graded. I want you to work with groups or with your whoever you want. You can work together, you can do it on your own. Do you want to practice some more or are you good? Let's test our knowledge on ABG. There's another one right here. See, I uploaded another one. So you should be good as far as practicing ABG. See, you have another. This one is just all numbers. So just practice, okay? So now I'm going to give you some ABG worksheets. And let's see.